Okay, so friends, in today's video we are going to derivatives or differential coefficients of inverse circular functions, and our first inverse function is sine inverse x. So we are going to find the derivative of sine inverse x. Let y is equals to sine inverse x. Let y is equals to sine inverse x. Okay, where mod x is always less than equal to 1 and the value of y means sine inverse x is between minus pi by 2 and pi by 2. Okay, this imply x is equals to sine y and dx dy is equals to dy of sine y. That's why, as I have already told you in previous video, clearly dx dy is equals to 0 if y is equals to plus minus pi by 2, and if x is equals to plus minus 1, then dy dx is equals to 1 by dx dy, okay, is equals to 1 by cos y is equals to 1 by root over of 1 minus sine square y. Okay, so for all mod x less than 1, from here we get that derivative of ddx of sine inverse x is equals to 1 by root over of 1 minus x square. Next is derivative of cos inverse x. Okay, as we know that sine inverse x plus cos inverse x is equals to pi by 2, where mod x is always less than is equals to 1. This implies ddx of sine inverse x plus ddx of cos inverse x is equals to ddx of pi by 2. Okay, pi by 2. This implies 1 by root over of 1 minus x square plus ddx of cos inverse x is equals to 0, implies ddx of cos inverse x is equals to minus 1 by root over of 1 minus x square. So this is the value of derivative of cos inverse x. Okay, so next is derivative of tan inverse x. Let y is equals to tan inverse x. X is between minus infinity to infinity, and the value of tan inverse x is between minus pi by 2 to pi by 2. Okay, this implies x is equals to tan y. Now both derivative both side we get dx dy is equals to ddy of tan y, okay, is equals to sec square y. Okay, which is always positive because of square. Okay, it is always positive. Next, this implies dy dx is equals to 1 by dx dy, okay, is equals to 1 by sec square y is equals to 1 by 1 plus tan square y is equals to 1 by 1 plus x square, implies ddx of tan inverse x is equals to 1 by 1 plus x square minus infinity to infinity. Okay, next is derivative of cot inverse x. As we know that tan inverse x plus cot inverse x is equals to pi by 2. Now both side derivative, okay, ddx of tan inverse x plus ddx of cot inverse x is equals to ddx of pi by 2, and derivative of any constant like pi by 2 is equals to always 0, so we get 1 by 1 plus x square plus ddx of cot inverse x is equals to 0. This implies ddx of cot inverse x is equals to minus 1 by 1 plus x square, had the value of x is between minus infinity to infinity. Okay, so our next derivative dy of sec y is equals to sec y into tan y. Okay, now dy dx is equals to 1 by dx dy is equals to 1 by sec y into tan y is equals to 1 by sec y into root over of sec square y minus 1. This implies ddx of sec inverse x is equals to 1 by x into root over of x square minus 1, where mod x is greater than 1. So our today's next derivative is cosec inverse x. Okay, as we know that sec inverse x plus cosec inverse x is equals to pi by 2. Now derivative both side, sec inverse x plus derivative of cosec inverse x is equals to ddx of pi by 2 implies 1 by x into root over of x square minus 1 plus ddx of cosec inverse x. Okay, cosec inverse x is equals to 0. This implies derivative of cosec inverse x. Okay, cosec inverse x is equals to 1 by x into root over of x square minus 1, where mod x always greater than 1. Okay.